SwayamPrabha. Digital India. Educated India.
Okay, I think we have been discussing about this question, what is chemical reaction engineering. I have given some examples like curd technology. Okay, if you really remember, even chemical technology also you will not forget, and even you won't forget about science, engineering and technology. Okay, and as I told you, best way to remember is telling to someone about what I have told you in the class. Okay, yeah, in the girls hostel or boys hostel, if you start telling, then you don't forget. Once or twice you tell, you will not forget, right. And also we have taken another example, that brick technology. Okay, but I did not ask, but how do you make scientific curd also we discussed, right. When he is taking 10 hours or 8 hours, then you have to go to science level of manipulating the genes of the microorganisms, then I think you can make really scientific curd. How do you make scientific bricks? Because what we have discussed was simple technology. How much water you have to add, what should be approximately the stones in the mud. Although if you put mud, it may melt and it may not have sufficient strength. So that is why. How do you make scientific bricks? In fact, there is tremendous amount of science is required. Yeah, tremendous amount of science is required if you want to make scientific bricks. That means using science, designing perfect bricks. Okay, how do you do that? Don't go to some other thing. We are talking about only mud and sand. Not fly ash will not give you scientific bricks. What is science in fly ash? It is waste. That is why it is science. So what is the science in fly ash? Tell me. If you have some other ideas, please tell me. It is a substitute for mud and yeah, that's all. But I am asking, how do you now make scientific bricks? The technology we know, the steps we know. How do you make that? So you have to think, you have to always extend your brain beyond what teacher told. Then only you have that research mind. Teacher tells something, then you have to also expand on your own from your brain a little bit, some other steps, okay, some other projections there. Okay, so whatever you believe the teacher tells, then you are a good listener, we will accept that. But you are not using your brain to sharpen and also your brain to do something new. This is what is, in fact, unfortunately, that is the problem with all our, with the society, our society, because that is why we are not able to make good researchers. The reason is that we always believe elders, mother and father, whatever they say, they may show bull and then they may say this is elephant, you will say yes, it is elephant. Okay, then you don't question them at all. Similarly, you don't question the teachers, you don't question yourself. So that is why we have a stable society, but again normal society, it cannot innovate or it cannot do something new. That is why even though our culture is one of the oldest, we could not produce anything at international level, producing technology, producing materials, producing some theories, all that because we simply believe God, and afterwards we believe our parents, and afterwards we believe our teachers. You should not believe any one of these people which I told, even you should not believe God. Okay, yeah. Now if you want to break away from science, otherwise you always say that okay, God gives something, we only use that, and even if you don't get food, okay, today only God gave me only one meal, so the remaining 2 meals anyway tomorrow he may give, at that time we will see. That is why because where is because you are trying to compromise, and in research you should be more aggressive, you cannot be compromising for each and everything. Okay, so that is why you have to also think, when I told how do you make curd scientifically, you should, 2 examples only I gave. The other example you should have thought on your own, that how do I make now, okay, he told me how to make scientific curd, but now how do you make scientific bricks? So at least at this point of time, that is why I think in schools also we are killing the innovation and we are killing the enthusiasm. What do we give in the schools? 10 kgs of books behind that fellow. Okay, he is already only 1 foot and above the ground, and by putting this weight again anti-gravity, it will pull down. okay, pull down. So, I think that he also cannot grow faster. Okay, always gravity is acting on him, no, another additional 10 kgs or 5 kgs load. Okay, that is all what we give him. We never allow them to think on their own. Even if they want, I think there were 2 ice creams, and if one ice cream is black and another ice cream is white, and this fellow wants to take that black, that chocolate ice cream. So, then mother, father, no, that is not good, you only eat this. You have to allow him to eat, and if it is bad, then he will come back anyway to this, if he does not like the taste. But we try to dictate, no, that is good, that is not good, you only do this or you only eat this. That is why we are not allowing. We are doing a wonderful job as parents to all of you. Okay? But when you become parents, do not do that. You allow your child to go anywhere, jump up and down, I think ask any question. Okay? You have to patiently answer. Then only I think do not give them book, do not give him books, do not give him even computer. Okay? And do not allow him to see the TV. Right? But ask him to think, that is all, because TV, that is all, what else is? No, really, that is what is most important, no. So, what does he get by seeing the TV? That fellow sits and then always looks at that cartoons, right. Cartoons are really innovative if he makes the cartoons, not seeing the cartoons. If he is able to draw on his own cartoons and then make the new cartoons, then fantastic. And what happens? At the age of maybe 3rd year or 4th year, he will get the specs. All of us got around 45-50 years, but most of the young children now, because of the contribution from TV, they are getting only 3rd year and 4th year itself this thick. And by the time he comes to engineering, he does not know where to go. I think yeah, because the thickness of this thing is so much, light cannot enter. Everything is black for him. In the mind, black, world is black. Everything is only black. Darkness only. So, that is why you should have thought, no, okay, now scientific bricks. How do you make scientific bricks? Just think. Huh? Sorry? Plastic. With plastic. Okay, why plastic? That means you throw away mud and then only start with plastic, or what? I am talking about given only mud and some amount of solids, how do you make scientific bricks? Earlier what we do, the technologist has a feel how much sand should be there, how much mud should be there, he mixes and then puts the right amount of water and all that. So, now I am asking you on large scale produce, like a chemical engineer, you produce like any other chemical, produce bricks. How do you do that? First you will go, mixer is required for long time. Before that, straight away you start with mixer. Yeah, how do you find out that? Either trial and error or from theory, where what size of the particle is good. What is the particle size? So, normally they may use 1 mm particle, okay, 0.5 mm particle. Why 0.5 mm particle is better than 1 mm, or why not 2 mm, or why not 0.1 mm? Sorry? Yeah, all that is the science, right. I think that way. Then even if you can go to, okay, can I use nanotechnology to make bricks? That means where nano powder, where I will bring all the powder together and then put them like a puzzle form where children play, and all the puzzles together, and then you will have the brick. That is pure science which you cannot realize at this point of time. You may do it. I told that example where that girl told me, how do you make sulfuric acid? Means hydrogen bring, sulfur bring, O4 bring, and then put together and then give it. Wonderful, really. If you are able to do the same thing for even brick, for any chemical, that is what is the pure science, but we are not able to realize that. So, that is why when you are now going for with scientific knowledge is how to find out what is the particle size and how these particles should be, orientation of particles inside the mud, how do you arrange them, like crystal structures, right. From the basic crystals, if you go, how beautifully those molecules are arranged using in the crystal structure, where you have sufficient strength also for those structures. For some structures have a lot of strength, some structures have weak strength, all that. So, using that science, can you also now design your brick? You see, for every technology, like for example, bullock carts. Bullock carts, we think that it is the lowest technology, because no science is, no equation is used for making bullock carts, right. So, then if you want to really design a scientific bullock cart, you need tremendous amount of theory, tremendous amount of engineering. Okay, in this brick technology, once you find out what is the orientation of solids and what is the right amount of mud, right amount of water, and also particle size, all that scientifically when you see. And how do you see scientifically? You have to arrange all that and try to find out which gives you the best toughness, strength. That is what is science. Then afterwards you have to convert that into product. So then you have to use engineering principles. As he said, I want to have this continuous brick making. So you mix at one point, actually you now need one bin with mud, another bin with particles, then both of them will fall into the mixer, and also another bin with water, right amount of water. All three, you should have flow rates. Okay, how do you measure flow rate of solids? Because I know BTech and MTech lab, or a BTech lab, you should have done how do you measure flow, liquid. Okay, but I think solids definitely you do not done. How do you measure? Huh?
Measure the mass flow rate.
Yeah, but how do you measure? Because continuously. No? Huh? Where? Very changing weight. Yeah, so that means the entire bin must be on a balance, where load cells and all that. You see, all that is the one what we have to use. I know most of you have not been exposed to this information, and all of us have been exposed how to measure water flow in the labs. That is why I asked that question, so that you can think again. So load cells are there, big platforms are there, now entire lorries are weighed. Okay, so that kind of thing you have to think now, and then say that yes, how do I measure now solids flow rates, because you have to send maybe 10 kgs per hour or maybe 15 kgs per hour continuously, then mix them. After mixing, what it has to go through, like a extruder, right, and then after that. Okay, so at the end, paste will not flow, that is why you have to put extruder, and now after extruder it goes to the mold, and this mold must be automatic, that mold, right. So that automatic means you design that mold, and then the moment the paste falls there, mold is filled up, and another thing will come, and then and apply also sufficient pressure, and then mold will go, this will be thrown out to the directly to for centering, drying and afterwards centering. Okay, drying, now you see, because it is a continuous system, you cannot wait now for 8 hours, or solar drying means 4 days, 5 days. So now you have to design a dryer where all this operation must be done very quickly. So then it has to go to center. Centering also, generally centering may take time, but even then you have to design that one faster. That is what is engineering principles you are using for brick making with the help of science. Now you define chemical reaction engineering with these examples. Now you define, because I have given sufficient examples. When engineering comes, when science comes, and when technology comes. Forget about technology now, I am asking chemical reaction engineering definition. It is engineering of chemical reactions. Okay. So now whatever we have discussed, that engineering principles we have to use now for chemical reactions to make them work. What are the engineering principles which you use in chemical reactions? Yeah, mixing is one, because I think when you take large quantities and then you have to mix them thoroughly, that is one. Huh? Flow anyway, if it is a continuous reactor, flow must be used. That is also an engineering principle, fluid mechanics. Heat transfer, how do you remove heat, how do you add heat. So that means all engineering principles, when you are applying to chemical reactions, that is called chemical reaction engineering. See, now you do not have to even remember that, because automatically when you know all these sequences, you know the definition already. Correct? No, if you remember that curd, if you remember this brick technology, because those things we told, because you know them already. Okay, how to make them, you know. But now applying those same things here also, applying that engineering principles for chemical reactions, like for example flow, if it is a continuous reactor, even if it is batch also, of course you know how to feed and all that. So then temperature, how do you control, how do you supply heat, how do you remove heat, and before that you also should know kinetics. Okay, what is the type of reaction what you have? It may be having an order of reaction, or it may not be having order of reaction. That means you need a rate expression. How do you get this rate expression? From experiments, kinetics, that is kinetic studies, and thermodynamics will not give you rate expression, and thermodynamics will not help you in actual reaction engineering, in the sense that for the design. For the design what you use only rate expression, not equilibrium data, right. Equilibrium data will come if it is a reversible reaction in the equation automatically, what is equilibrium equilibrium constant capital K also will be present in the rate expression, but that rate is important. How do you get the rate? By doing experiments, or if it is already given that this is first order, you simply write minus R A equal to K into C A. So, all the engineering principles you are using that, and what is the difference between chemical engineer and chemist now? Chemist will not bother about the flow, even if he does continuous, but it is only very small quantity where you will put a jar there and then from there drop by drop it will fall, and drop by drop if you make in industry you can never make that kind of large quantities. That is the difference between chemist and chemical engineer, and we do not have to blame him or he need not blame us, because that is his duty or her duty as chemist. What is that? To find out how the molecules are moving, to find out how the molecules are reacting, and how do you get finally whether this reaction is happening or not, that information, but his scale is always very very small. So, now you see with these examples you can even draw the flow chart. If I ask you now curd making flow chart, can't you make now? Easily you can draw the flow chart. For example, brick, you know that initially you should have the bins and then both have to fall, and then you have the mixer, from the mixer it has to go to again extruder, from extruder it has to go to mold and all that. And now you can imagine any process, if you, that is why process is important, mind is important. Mind means thinking is important. If you think about the process step by step, what is really happening, where the heat transfer is coming, where the mass transfer is coming, where the reaction is coming, where the fluid flow is throughout if it is a continuous system. Even if it is batch system, it is continuous. I mean all the time you have to pump the liquid after the reaction is over to store, or from the reactant storage to the reactor. So, all these things are happening already. So, now that is why even chemical technology will be very easy by answering these questions what we have. That 5 questions will give you the entire knowledge, okay, 5 or 6 questions, right. What is the first question? Chemical engineer, what is chemical engineering? Then what does a chemical engineer do? Yeah, I think you have forgotten, yeah, already. Yeah, what is the third question? How does a process flowchart start, and then
what is chemical reaction?
What is the next question?
What is the information necessary for reactor?
That is the question now. What is the information required for reactor design? Okay, I think this is very clear now. I think you can see, I do not have to even now define, you know how to define now chemical reaction engineering, right. That is using chemical, using engineering principles to conduct chemical reactions. That is all. I think the first person who cached that name after this after the seminar is over, can you guess who? Huh? Who cached that name? Excellent, Levenspiel. Immediately he got that name and then put the name of his book as Chemical Reaction Engineering. Fantastic. Levenspiel is really great. The way he makes things simple. Okay. Before that also there are 2 more books. Wallace, there was a book, WALAS, Wallace. Okay. I think chemical kinetics for kinetics for chemical engineers or so, that is the title. But no, not easily readable. That is a good book, but not easily readable. Then at the same time, even James Smith book, yeah, chemical engineering kinetics, yeah. So that book also was there. But those books are not that famous when compared to Levenspiel. Why? Because the presentation, the way he explained things, presentation is really beautiful in Levenspiel. So he immediately took the name and then put it for his book as Chemical Reaction Engineering, because he has already used that book. Yeah, I know the Schmidt recently, maybe I think 5-10 years back only, that one, engineering of chemical reactions. Again, what a wonderful name, engineering of chemical reactions. That means only he just changed this words, that is all, engineering of chemical reactions instead of chemical reaction engineering. Okay. So the next question was, yeah, what is that? What is information? What information is required? What information is necessary? Okay. Yeah, is necessary for reactor design. Okay. Can you tell me what is that information required for reactor? Rate of reaction,
Performance equation,
Conducting pattern.
performance equation,
volume of the reaction, volume of the reactor,
Conduct.
flow rate. Yeah, see, you know the volume of the
Performance
reactor, you know the rate, and you know initial concentration. Yeah, you also know conversion.
conducting
You also
pattern,
know conversion. Then where is the design? All the questions you know. Everything you are telling that you need volume, already conversion. You have to give again. If I give volume, if I give conversion, if I give CA0, if I give rate expression, there is no design. Everything is known. And you are not told tau. Okay, you should also know tau. Okay, yeah. If everything is known, where is the design? Huh?
equation,
Amount of the product. Yeah,
Product,
okay, that's
yeah.
correct. Because I think flow rate indirectly, that gives the flow rate. Yield will not come in the design because where are you using yield to design the reactor? It is always conversion, because the basic expression is written in terms of only reactants. That is why reactants only get converted. Okay? Yeah, but still you have not answered my question. What is necessary? What is the information that is necessary for reactor design? Okay, I will give you another some data. You just tell me whether this is just sufficient for reactor design. So I give you K as, let us say, 1 minutes per inverse. Okay, and then see, I will also give you. Someone is asking initial concentration CA0 as 1 kilomole per meter cube. Yeah, and I will give you V as 1 meter cubed per second. I will also give you FA0 as 1 kilomole per second. Okay, I will also give you XA. XA equal to, let us say, 90% conversion. Do you have all the data for reactor design?
type of reactor, contacting
Conduct. Patch or
the
continuous.
which reactor we are using.
We have to mention that.
Yes. Performance equation is not wrong.
Oh, performance equation. Huh?
Catalyst, sir.
You want to find out? Phase of the
Yes.
element.
Phase of reactor.
Rate equation is required.
Okay, homogeneous.
Rate expression is not given.
Huh?
Rate expression. It's first order. Okay, first order.
K is given as minutes inverse,
Per
it is the
minute.
first order,
First order.
which is totally wrong. Okay, it need not be first order for many cases.
Okay.
Because our mind is still in the LKG, that is why all of you say that it is first order. This is truly valid only for homogeneous reactions. The moment you go for heterogeneous reactions, it may not be valid. Because rate can be expressed based on various things.
Pressure.
Because homogeneous reactions we base normally on moles converted per unit time per unit volume. If you base only on unit volume, then this this indication is right that this is first order. That is why it is only strictly for homogeneous reactions where rate is based on that. Rate can be based on surface area, rate can be based on weight of the catalyst, rate can be based on mass surface area, volume of the catalyst, volume of packed bed. So there are so many things which you can have, that also we will discuss later. So that is why the most important thing it is missing from here is I have not mentioned what kind of reactor. Okay. Then Levenspiel has put all this information that is necessary for reactor design in this wonderful diagram. I think some of you may be knowing, because she is telling already performance equation and all that. I do not know how many of you used Levenspiel book. All of you. All of you. Yeah, then you must know, but I do not know what is the meaning, whether you know really the meaning of this diagram. Yeah, what is here? Reactor. This is input, this is output, Yeah, then we have here what is called kinetics, and here we have contacting. Yeah, some more things are there here. In kinetics we will say here chemical and physical. Physical, and in contacting you have batch and you have continuous, and in continuous again you have not semi continuous, I think yes, we have here to maintain the same thing. Okay, here I have, I hope you understand this PF is plug flow. I think first time I have to write because others also are there, plug flow and mixed flow. Yeah, mixed flow. So now this entire thing also we can imagine as a performance equation, design equation indirectly, is output is a function of input, kinetics and contacting. Okay. This is a function and this is the performance equation. Yeah, I think here this bracket is there here. Okay. Yeah, this output means what do you get from this equation? I mean, this output means what parameter you are expected to calculate if that is an equation.
Conversion,
Conversion,
Amount of
volume of reactor.
volume of the reactor. Yeah, which one is right or both are right?
Both are.
Both you have to calculate.
No sir, given one
Anyone.
you can calculate that.
Yeah, given.
Given one you can calculate.
Always the problem in chemical reaction engineering is that given the volume, find the conversion. Given the conversion, find the volume. Whenever you are designing a new reactor, because in reactor volume you do not know, that is why you have to always assume that what is the conversion. No one tells you what is the right amount of conversion. Okay? And ambitiously speaking, all of us want 100% conversion. But if you go to 100% conversion, the volume of the reactor will be infinity. It occupies the whole universe. You do not have space to go and operate. You should be inside the reactor. Okay? Yeah. So that is the reason why you have to assume some conversion, economically viable conversion. Otherwise, you know, from 90% conversion, 95% conversion, 99% conversion, the value of volume will tremendously change. When you derive the equations, when you calculate, you will know. So from 0.99 to 0.995, tremendous exponential increase. Okay, very steep increase. So volume will become infinity when you go to 0.99999 like that. So that is the reason why economically viable conversion, which only you know. As engineer, you have to have that feeling that okay, beyond this. Nowadays, of course, with computers we can simulate with 0.99999 and then 0.999, 0.999, 0.9 like that. Okay. So then you will have what will be the total volumes you are getting. So depending on those volumes, you can choose what is economically viable. Why economically viable means, if the volume is infinity and you have to bring the material which is already available in the whole universe and then try to design. Volume itself is infinity. Okay. So materials of construction is required, and how do you supply heat, how do you remove heat, all these things is a problem. So that is why economically viable. In all these definitions, always that economics is coming for engineering. Okay. That is why another simple example I will tell you to make you remember that as a scientist I do not have to worry about economics, right. One example is let me say this, that I have invented a small pill, okay, tablet, and if I take the tablet lifelong I do not have to take any food, because that gives you sufficient amount of nutrition, energy to the body, nutrition, energy, everything to the body. But only problem is the cost of this tablet may be $1 billion. Okay? Scientist can say that cost of my tablet is only $1 billion. Okay? You cannot find out any fault with him, but as an engineer, if you are able to produce that one for 1 paisa, then there is no chemical engineering, there is no electrical engineering, because who will, and after all we are all working only for our food and life. The moment you have that food, very happy that 1 paisa somehow you get it, and lifelong you do not have to eat, and then you can always happily jump and dance and all that. You know, this place will become really paradise. You know paradise what they do most of the time? Huh? Yeah, then yeah, what do they do? In paradise, at least the stories tell us that there are 4 beautiful girls. Who? Amba, Urvashi, Manaka, Tilota. Always they will be dancing, others will be always watching them. That's all. That is what they do in paradise. So our place also will become paradise. Okay? So we will have many Rambas here. They have only one Ramba. We have many here, beautiful people on this planet. Okay? So that is why, you know, that is the difference between a scientist and an engineer. Always when engineer is making products, it should be as economically viable, and also it should be affordable by the people who have to buy those products. Otherwise, what is the point in making this wonderful pen with nice plastic and all that, and then say that again this is $1 billion. Who will buy $1 billion? I think even Ambanis do not have, Tatas do not have. 1 billion they have? Oh, they have. Huh? Oh my God! I am a old generation guy, where I think our dosa used to cost only 10 paisa or 15 paisa. Okay, dosa, or idli maybe only 5 paisa. So that is the generation which we belong. So the moment you put more zeros, I think our mind will not work. The billion has many zeros. If you ask me, sir, billion how many zeros? I don't know. I don't know. I know how many zeros 10 has, only 1. That's all. Okay, anyway. So this is the information, and you know, this is economically viable thing is very important, and in all engineering, irrespective of chemical engineering, every engineer should feel that yes, he has to produce anything, whatever he is producing. If he is constructing a house as civil engineer, then again it cannot be costing, you know, millions or billions of dollars. If he is able to make small houses for everyone, excellent engineer. And for that again, civil engineers alone cannot live, because chemical engineering should be there. Why? They have to supply cement. Correct, no? Yeah. And inside the furniture also, I mean, wood we are not making, but I think that beautiful paintings for wood, varnish for wood, and carpets, all this material. Huh? Yeah, Fevicol to, if they do not have Fevicol, they can use nail size. Earlier they were using only nails nicely, because I think on this planet even iron is not available, so that is why we gone for Fevicol. Yeah, you are telling something? Huh?
For nails also we need blast furnace.
Blast furnace we need. Blast furnace again, the technology there is again chemical engineering, because that is gas solid non-catalytic reactions. Okay? This iron is converted, iron ore is converted to iron, right? Yeah, that also we will discuss in the next class, and next course. Yeah, so that is why this even electronics engineer, if you produce TV for maybe again billions of dollars, who will buy? Okay, but that is why now the TVs and all that, I think this is electronics which where the cost of electronic components are every time decreasing. That is the only thing. All other costs are increasing. Okay, you can see earlier what is the pen drive, and now what is the cost. Earlier what is the cost of CD, now what is the cost of CD. I think I was surprised. I think some time back my students were telling that even for 7 rupees, 3 rupees, 7 rupees you get a CD, and I was remembering that it is 120 rupees when I purchased long time back. Okay, now I only take from others. Okay, yeah. So that is the kind of thing, and like that in every engineering, if you are able to produce goods cheaper and cheaper, this planet will be really paradise. Okay? And even producing not only materialistic things, even for food. Even now we do not have much food. Many people are there without food. If you are able to produce that food, excellent fertilizers, where immediately before putting the fertilizer itself, the crop should come. If it smells, okay. The moment you show the smell for the plants, if they are growing so happily, why not? Just I think have lots of smell and then just breeze over the the fields. Then automatically you will get very beautiful fruits and then all wheat, rice, all that. Then the entire planet will be so beautiful. But for human mind, nothing is impossible. That is why I like science fiction movies. I was telling because their mind, how beautifully it has imagined. Particularly that Avatar movie, the entire planet was in the mind of James Cameron. He is the director. He was the director. He is the director. Entire planet, right? And also how he imagined the people. What should be their height? What should be their color? And everything. Sorry. Yeah, floating mountains. That is a new concept. Floating mountains. I don't know that floating mountains are really floating because density difference and all that is there. I mean, anything which is floating, having more than density of air, it should fall. So that air should be very, very thick. I think very dense air. Otherwise, they cannot float. No. Otherwise, the mountain should be like cotton. Mountain. I mean, there are big trees also on those mountains, right? And all that imagination, and I think the best imagination in that movie which I liked is putting that pigtail to, for the when they are riding the birds or horse. That concept is so beautiful concept because that we can also use. Okay, you have to go today and then put your pigtail to CRE book, 11th spell book. Then everything you will be part of that. Concept is so beautiful. And in our world scriptures, this is there already. Whatever you do, you have to be part of that. Whatever you do. So that means that he is now physically showing you how to become part of that. That is all the difference. We have already, whatever you do, you have to completely immerse in that. When you do that, I think Dhaneshwar is one of the wonderful names. The moment you close your eyes and meditate, you will be automatically dissolving in whatever you do. In whatever you do, the moment you are preparing for a CRE exam, close your eyes, the entire CRE book should be before you, each page, page by page. Then automatically you are part of you because you are seeing by closing your eyes that book in your mind. I told you we have all of us as mental screens, not mental screens. All of us are one way or other mental, that is different. But all of us have mental screens. So those screens will automatically project whatever we would like to have, if you have the familiarity with that. I don't know whether I asked in this class or somewhere else. So the moment I tell Delhi, what do you remember immediately? Only I ask you? Yeah. So that means immediately, depending on your exposure, someone may imagine in his brain or in the mental screen Qutub Minar. Someone may see that Gateway of India, someone may see the Parliament Bhavan, someone may see the Palika Bazaar where they are interested in shopping and all that. Okay. So that is the kind of mental screen I am talking, and that mental screen can be beautifully used for our either CRE or any subject, for our chemical engineering. That is why I think I have some exercises for the student. Just go and sit down in your room and then just imagine a heat exchanger and then try to plot the temperature profiles. You will never forget the subject if you do that. Imagine a distillation column and then just imagine where is the feed, how the temperatures are varying from bottom to the top, or how the concentrations are varying. That means indirectly what I am asking you is to plot temperature profile and concentration profile, right? And now you can go to extraction column. In the extraction columns, it is a column. There may be mixer settlers also, one mixer settler where it mixes and then settles in some other one, all that. So there what kind of concentration and temperature profiles you will have? You just sit down and imagine and try to plot all that in your mind. You will never forget the subject. It is not the marks which are important, which maybe you may be getting sorry, yes, in IIT Madras we have yes, 10 out of 10. In some other places it may be A may be 10 out of 10, or it may be 100 out of 100. Some many university also are giving still the actual marks, right, absolute marks. So when you have 100 out of 100 on the paper, does not mean that you have 100 out of 100 knowledge in that subject. But when you do the way I am telling you, just imagine and then try to plot in that subject whatever things what you have gone through. You will never forget the subject, and all the way subject is with you and marks are in your cupboard. Correct? No, you take mark sheet and then you cannot carry every day. So, you will just put somewhere else, but whereas this brain you cannot keep anywhere. Okay, it has to come with you wherever you go. So, then I think you will beautifully understand whatever is happening in the subject. That is what is the interest you have to develop. I say everything is interest, that is all. And most of us are skeptical. Chemical engineering, so what? Distillation, so what? Reaction engineering, so what? So, the so what is a very bad word, like cracking the exam. Okay? We have either so what or cracking the exam. That is why simply we are indifferent for the subjects, and every subject is a wonderful subject. I tell you, I have shown you what is the beautiful amount of science that is there even in brick technology, bullock carts, anything you see in nature, what is made by us, but made by nature also is wonderful. So, that is why we try to understand nature first and then try to mimic in our things. Most of the things what we produce, like flying aeroplanes, only birds. Our gods used that Garut Manta, it goes, and then and we also had what is called Pushpak Viman, right? Pushpak. So, all that were there in the mythology, maybe they were imagining. I do not know whether at that time they were really existing or is maybe their imagination, because when people write the stories beautifully they can write. Again science fiction at that time. If there was science fiction at that time, you would have created in the mind that this is Pushpak where people can travel at that time. We did not know that, right? Because nowhere to go back, and only science fiction it is possible to go back into the past and also to go back into the future. But right now we are not able to do that. Maybe it may come after some time, we do not know. If you are able to do that, then probably you will get. So, that is why I think this chemical reaction engineering definition on your own you can now create, provided you do all that what I have told you, that imagination, thinking about these examples. Then afterwards when you ask this question, this is the one for the entire, I may teach you 10 reaction engineering courses, I can never come out of this diagram. And if you also understand the meaning of this diagram, what do you mean by physical kinetics, what do you mean by chemical kinetics, what do you mean by contacting, okay? And what do you mean by batch, continuous? In continuous again you have two types of ideal reactors. Actually that is ideal contacting, because you can have non-ideal contacting, but you will have lot of varieties. But ideal contacting, this is a wonderful information for the reactor design. I thank really Levenspiel for this. Everything, whatever you may have, heterogeneous reactions, homogeneous reactions, everything you may have, but still you cannot go out of this reaction, out of this diagram, out of this performance equation. Who gives input to us? I have already told you. What do you mean by input? Input is not given by chemist. How do you get raw material? How much is required? Product. From product you have to back calculate and then say that she was telling me that I think we need the flow rates, right? How much you have to produce, okay? That how much you have to produce is input. That is in Levenspiel language FA0. FA0 moles per second, not volumetric flow rate, molar flow rate. That is what this one, FA0. FA0 already you have with you, because someone went to market, because you know that this product has demand. Someone went to market and then they found that this is the total demand in a year. So, that is your plant capacity, that is your FA0 when you convert that product into reactant through stoichiometric equation, okay? That is one parameter, this already we know, okay? Then next one is kinetics. From kinetics what do you get? Simply minus Ra, right? Order of reaction, all that I think every reaction need not have order first of all. So, kinetics will tell you what is rate minus Ra as an expression. It may be K into Ca if it is first order simple expression, or it may be very complicated with so many terms in the numerator, in the denominator, everywhere, okay? So, that means we have to now understand for my reaction where may I have the stoichiometry, what kind of kinetic expression I get. That is what this, there I have to work. Here I do not have to work much. Why? Because it is market survey. Simply I will go to market and then take the statistics and then say so much demand. We do not have much work there. And here I have tremendous amount of work. In fact, this is the most difficult step in chemical engineering. In chemical engineering itself, I can tell you. Then what is this one? Next one. Next one is what type of reactor you are going to use. That is all what you have. If you know what type of reactor, let me say batch reactor you have, batch system, right, and then I know kinetics, I know the input, how much I have to put there, right. Then what is that I have to calculate now? If I want to design reactor, then I should assume also conversion, and then fourth the volume can be calculated. Or if I am already having a reactor and I put all this, because I have a batch reactor, I know kinetics, I know how much I have to dump into that, because contracting is batch reactor. So, then this will be conversion, because volume I know already, that will be conversion. Okay. So, that is why either you have to assume conversion or you have to assume volume. And always for a new process, it is only volume I have to calculate. For an existing reactor already old process, there is already a reactor. Now, I can only calculate what is the maximum conversion I can get from that volume. That is all throughout, not only in in reaction engineering, everywhere it is same. Okay. What are you doing in distillation? You are first assuming 99% purity, then calculating number of stages. If you know number of stages, what do you calculate? Because that problem you never thought normally. If I give you I have 10 plates, and if I also give you composition, there is no problem, but you do not have to do anything. But always what we give is that either give number of plates and then ask you to calculate what is the composition you get, and also flow rates and all that you get by material balance, or give you the extreme compositions and ask you to find out how many stages required for that. Heat exchange. If I give you the temperatures, you calculate area. If I give area, you have to calculate temperatures, and if I give area plus temperatures, you do not have any problem. But I think even if I give in the examination, you may try to calculate, because your idea is, oh, there must be some trick, so let me calculate. You never write simply that everything is given, I do not have to do anything. In fact, that kind of questions I will give, okay. Because you should know, I say you should know what is wrong, what is right. It is not that every problem you have to solve. So, that is why be careful in my question papers. So, that is the kind of everything may be there, you do not have to do anything. If you write that nothing to be done, you will get marks for that, because I think that is a great information for me, because you are able to identify everything is there. That itself is a very good happy answer for me, because you know that subject, you know that problem. That is the reason. So, that is why in next classes what we discuss is only about this. We will start from kinetics, and then we also go to contacting, and we will see how do we combine them, and then after combining what kind of things we can do with that combining expressions. Many things we can do. Okay? We will close here. Thank you.